Hi, meet you again. Today we are going to learn Chapter 6.3 Tangents to Circles, Part 3. Our learning standard is to make and verify conjectures about the relationship of angle between tangent and chord with the angle in the alternate segment which is subtended by the chord. Based on the statement on diagram 1a and diagram 1b, we can conclude that angle x is equal to angle y, whereas angle theta is equal to angle beta. This is because the angles between the chords and the tangents are equal to the angles at the alternate segments subtended by the chords. Look at example 17. The diagram on the right shows triangle KLM, triangle KLM, and PMN is a tangent to the circle. Determine the angles in the alternate segment for angle PMK and angle NML. The angle PMK is equal to angle KLM, whereas angle NML is equal to angle LKM. See how it works. Angle PMK, the exterior angle, jump into opposite. Angle PMK is equal to angle KLM. Next, angle NML jump into opposite. Angle NML is equal to angle LKM. Let's see example 18. The diagram on the right shows the triangle ABL inside a circle. Triangle ABL is inside the circle. Given that KLM is a tangent to the circle, determine the value of x and value of y. X is equal to 60 degrees because x is an angle in the alternate segment of angle KLA, which is subtended by chord AL. Y is equal to 54 because angle LAB is an angle in the alternate segment of Y, which is subtended by chord BL. Let's see the diagram. Angle 60 jump into opposite. X equal to 60. Exterior angle Y. Exterior angle Y jump into opposite. Y equal to 54. Let's see this diagram again. See the arrow. Exterior, jump, opposite. X equal to 60. Exterior, jump, opposite. Y is equal to 54. Let's do this mind test 6.3D. State the pair of angles with the same value in the following circles. Find what are those exterior angles. The exterior angle that we may found is X and Y. Let's do X first. X jump into opposite. X is equal to A. Exterior angle Y jump into opposite. Y equal to Z. Let's do this B. Can you see there are two triangles in the circle? Let's see the first triangle. You could see that X is the exterior angle of the yellow triangle. Exterior X into opposite. Therefore, we say that X is equal to B. Let's see another triangle in the circle. Find what is the exterior angle to this triangle. The exterior angle for this green triangle is Y. Y jump into opposite. We say that Y is equal to A. Now let's do 1C. Again, how many tangents can be found inside this diagram? There are two tangents here. The first tangent, the second tangent. The first tangent is attached to this triangle, whereas another tangent is attached to this triangle. Let's see the first tangent. The first tangent is attached to this triangle. Focus on its exterior angle. Exterior angle Z jump into opposite. Therefore, Z is equal to A. Now, let's see another exterior angle F. Exterior angle F jump into opposite. F is equal to E. Let's focus on the second tangent. This is the tangent, and the triangle attached to the tangent is this triangle. Find the exterior angle. The exterior angle X jump into opposite. Therefore, we say that X is equal to Y. The diagram on the right shows a circle where AB is a tangent to the circle. Given that angle BAC is 42, calculate the value of X. You are given a tangent AB. You may extend the AB line. Then you also notice that the isosceles triangle is inside the circle. Triangle ADB is an isosceles triangle. The question is, what is the exterior angle for the triangle? The exterior angle attached to the tangent and the triangle is 42. Angle 42 is labeled over here. Then you may find out what is the angle for DAC and angle DCA. How do we calculate them? The total angle for the triangle is 180. Minus it with 42, you may get 138. That means each angle is 69. Angle DCA 69, angle DAC also 69. Look at the bigger triangle ABD. Total angle ABD is 180. X is equal to 180 minus 42 minus 69 minus 42. Can you find the value of X? See you again. Bye-bye.